Okay, maybe you've tried this problem already. I hope so. So if not, kind of fast forward and see how you did. The amplitude of this curve is 1/3. The period is 2 pi, and I have to divide by a fraction for the period this time. So now the coefficient in front of x is a fraction, which isn't uncommon. This actually turns out to be a pretty nice problem because when you take 2 pi and divide it by 1/2, you multiply it by 2 over 1, or just multiply it by 2. So the period is 4 pi. Then the displacement is the opposite of this negative value, so that's kind of nice. So this one's going to displace to the right. It's going to be a positive. And then when I divide by the b value, which is 1/2, again, I'm going to multiply by 2 when I divide by 1/2. So I'll multiply by 2 over 1. If you want to, don't forget that you can go 2 goes into here once and into there 4 times. And so the displacement for this one is pi over 4. Okay, ready to draw the curve. So I draw my axes. I pick a spot to represent the displacement. So I'm just going to pick a point right here and call that pi over 4. That's where it's going to displace. It's a cosine curve with a positive amplitude, so it's going to start up here at 1/3, but not at 0, 1/3. It's going to start at its displacement, pi over 4, 1/3. Be careful with cosine curves. Try to give an arc to those. A lot of people draw these like V's. I really don't like it when you draw it like V's. This is where it's going to end. So I have to start with that point, and I have to add 1/4 of the period to it. 1/4 of this period, I'm going to come on over here and write that down. So 1/4 of the period is 4 pi. So when I add 1/4 of 4 pi, I'm going to either add 4 pi over 4, which is just pi, but it's going to be easier to add 4 pi over 4 to 1 pi over 4. Much easier. Again, you've got 1 pi over 4 as your start point, and you got to add 4 pi over 4 to that to get you to the next quarter point, which is 5 pi over 4. So I left the 4 pi over 4 as is, so these would have common denominators. So this spot right here would be 5 pi over 4. I'm right there, so I'm going to add 4 pi over 4 to that, and I'll get to 9 pi over 4 for the next quarter point. If you could, I'd rather you didn't show the work, by keep adding 4 pi over 4 here. I'm going to do it just to help those of you that fractions are just really a killer. So I'm going to add 4 pi over 4 to that. 9 pi plus 4 pi is 13 pi, still over that common denominator of 4, and now I'm sure you all can do this. So again, up by 4. There's 1. Up by 4 is 5. Add 4 to that is 9. Add 4 to that is 13. Add 4 to that is 17 pi over 4. If you took this 17 pi over 4 and subtracted your starting point, which was 1 pi over 4, you'd get to 16 pi over 4, and 16 divided by 4 is 4 pi, and that would show you that to go from here to here, you successfully went through the whole cycle, 4 pi radians. Again, stop the video, do the next one on your own. This one's kind of interesting. So the amplitude is 2, the period is 2 pi divided by b, which is 1/4. So 2 pi times 4 over 1, or just times 4. So the period is 8 pi. It's kind of nice when these end up being relatively whole numbers, if you will. The displacement is the opposite of this positive, and then I'm going to use the pi over 2. I'm going to divide by the b value, which is 1/4, and when I divide by 1/4, I multiply by 4 over 1. That's a negative 4 pi over 2, which is a negative 2 pi. So this curve is displaced, if you will. It kind of seems like a lot that it's displaced. And it's a negative 2 pi. So I'm going to come on over here and kind of put a large distance between the origin and its displacement, just because it seems like it's a larger number than we've been dealing with. I've got a sine curve. Its amplitude is 2. Remember, sine curves normally start right here, but this one's going to start right here. It's going to go up to 2 and down and etc. But before we draw this, because I've been mentioning to you that sometimes it's a little questionable as to where this curve goes for its, next quarter spot. So I'm going to go ahead and take a quarter of the period right now because I'm kind of noticing something funny about this one. So a quarter of the period, which is 8 pi, so 4 into 8 is 2. So the distance to go from the first point to the next point is 2 pi radians. So look, we're at a negative 2 pi. So it happens then that I know that this curve, the topping out point for the sine curve is right here. And the next point is right here. And the next point is right here. And the next point is right here because a quarter of the period is 2 pi. So I want to go from here to my x value of 0. I'm going to cross the x-axis at 2 pi, go down to this 4 pi, back up to the 6 pi. The distance from here to here is the 8 pi, and I really, because it was so simple, didn't have to do any fractional work to find a quarter of the period and add it to my displacement point right here. I didn't mean to circle this, but to start right here. Also, would you notice that we could call this a cosine curve because it starts up at 2. So another equation for this problem, I forgot to put my amplitude in front. Another equation for y equals 2 times the sine of 1/4 x plus pi over 2 is 2 times the cosine of 1/4 x with no displacement at all. So this equation and this equation are the exact same equations. And if you would put them into your graphing calculator, and I think if I were you, put them both in. If I were you, I'd hit my zoom key on that top row, and I'd go zoom trig, which tends to be, I think, on most calculators, item number 7. So go zoom trig. And see, especially if you have a newer graphing calculator, see if the first curve, which is 2 times the sine of 1/4 x plus pi over 2, which comes in one color, and see if the next color curve just falls over top of that. So again, writing a function based on data becomes relatively simple. Let's look at this next one. Ends up that this one's got some, we lose pi in the quarter points in this one. The amplitude is a negative 25. The period is 2 pi divided by 3 pi. See the number in front of x? So see the number in front of x? That's 3 pi. So the pi's reduce and the period is 2/3. If this was an application, it would mean 2/3 of a second on the x-axis, likely second. This is a minus sign. So I want it to be the opposite, so a positive pi over 2 divided by 3 pi, which is 3 pi over 1. So I'm going to write this as pi over 2 times 1 over 3 pi, and then I'm going to cancel out the pi's top and bottom. 1 on top, 1 on the bottom means they're equal to 1. And you have left for the displacement of this curve 1 over 2 times 3, which is 6. So I'm going to try that again. If I draw it a little longer, maybe it'll be vertical. And this curve displaces 1/6 of a unit. The period is 2/3. I'll come back to that in a minute. It's a cosine curve that starts at a negative 25. So I'm going to start it right here. I'm going to show one cycle, or I'm sorry, a quarter of the cycle, another quarter, and another quarter, the last, right there. Let's put in our tick marks. I'm going to find out what 1/4 of the period is. If you don't mind, I'm not going to reduce first. So in the numerator I have 2, in the denominator I have 12. So a quarter of the period is 1 over 6. So to this 1 over 6, I have to add 1 over 6. This is another reason why I don't bother reducing, because 1 over 6 plus 1 over 6, 2 over 6, add another 1, 3 over 6, add another 1, 4 over 6, add another 1, 5 over 6. Come back and reduce this to 2/3. Come back and reduce that to 1/2. I don't typically mark you wrong if you don't do that, because I'm so happy if you get these quarter points. The one other thing I'd like to notice is if I could go back and do it all over again, because I'm particular myself about drawing these regions, these areas to be equal in length, because they're all equal to 1/6. I'm unhappy with this length right here. I wish this y-axis was over to about right here so that it demonstrated that, so I'm going to do it in blue. I wish it was right here, because the distance from here to here is 1/6 as well, and I could see how I could make this one into a upside down sine curve as well, with 3 pi as the value in front of. So I'm pretty sure that one would be y equals, and I'm doing this off the cuff, -25 times the sine of 3 pi x with no displacement, but just an upside down sine curve. Again, I put my y-axis right here, and therefore I didn't kind of notice it at first. Let's see if we have time to do the next one. I'm going to do this one really quickly. You should pause the video and do it on your own. So I mean really fast. I'm going to do it. Amplitude, period, reduces, opposite of C divided by B. Divide by 4 means multiply by 1/4, negative pi over 24. So I can do these quickly if I want to. Darn it. Let's see, I'm displaced to the left, a negative pi over 24. Sine curve, but it's upside down. I'm just going to go ahead and assume that it crosses the y-axis, not even paying attention to see if it does. Go right here. I'm going to put the 25, oh, sorry, it's a 3. I was back on the other problem. So the amplitude is 3. Got to make sure I get my -3 down here. Got to find this quarter point, that one, and this one. Quarter of the period is a quarter of pi over 2, which is pi over 8. So I'm going to take this negative pi over 24, my starting point, and I'm going to add to it this quarter of the period. I'm going to change it into 3 pi over 24 so that I can add these with common denominators. So a -1 pi plus 3 pi is 2 pi over 24. I'm not going to reduce that. Not real happy with where these look kind of equal, because this one is only 1/24 and this is 2/24. Remember, I'm adding 3 pi every time, so 2 and 3 is 5 pi over 24. Add another 3 is 8 pi over 24. Add another 3 is 11 pi over 24. Could come back and reduce. I'm looking at just to make sure I didn't make, yep, looks like I did this well. Could reduce this to 1/3, could reduce that to 1/12. I'm not going to bother at this moment.